Hello, lesson 6.8 is expected value and fair gains. So expected value, first of all, this is the average result over a long, it's an R, I promise, period of time. Ugh. The average result over a long period of time. Okay. And if an outcome in an experiment has probability P, then n trials of the experiment, the expected count of the outcome is NP. I'll show you what this means. So suppose a town has 25,000 adults, the unemployment rate is 5%, and you sampled 200. What is your expected count? Well, in this case, your n equals 200, and your probability is 5%, or 0.05. So then your expected value or expected count of unemployment would be 200 times 0.05. So this is NP equals 200 times 0.05, which is 10. Assume that 78% of students at Minnesota University take a mathematics course. If you have 3,400 students enrolled, how many students are expected to take a math course? Well, N is 3,400. That's our number. P is 78%, which is 0.78. So then NP is 3,400 times 0.78, which is 2,652. In any given year, suppose you're enrolling N students, write an expression that represents the expected number of students enrolled in a math course. Well, NP, in this case, we don't have an N, we're just leaving it as a variable. P was 0.78, so if you write this a little more properly, you have 0.78 N. So however many students there are, you'd multiply by 0.78 to find the expected number of students enrolled in a math course. Example 3. The wet season in a region is 125 days long. Sorry about that. And there's an 85% probability of rain on those days, while the dry season is the other 240 days, and there's a 10% chance of rain on those days. Okay, the expected number of days of rain. Well, we're looking at the probability of rain. So for 125 days, there's an 85% probability. So there's our N and our P for this one. So we have 125 times 0.85. So that's part of the year. We're trying to find the whole year. So the other 240 days, which is essentially our other N, there's a 10% chance of rain. So this time our NP is 240 times 0.10, or 0.1. So we end up with 106.25 plus 24. So the expected number of days of rain is about 130. It's out to be 130.25. Okay, you flip a coin one time. Heads, you win $5. Tails, you lose $2. Calculate the expected value, where all our events are heads or tails. Not that many things happen when you flip a coin. It's not really like an exciting experiment, right? So your outcome when you get heads is $5, positive $5. When you get tails, you lose $2. That's a negative $2. Probability, I mean, you have a 50% probability of each, right? So 1/2 or 0.5. For our expected value, we multiply across. So 5 times 0.5 is 2.5, and negative 2 times 0.5 is negative 1. So our total is 1.5, meaning our expected value on average when you flip a coin would be to get $1.50. Obviously, you can't ever get $1.50, but if you do this many times, if you do this a bunch of times, your average would be $1.50. Fair game. So a fair game is where the expected value and the cost of a game, or the cost to play a game, of chance. So the expected value and the cost of a game of chance are the same. So you draw a marble from a bag. There's 5 blue ones, 3 gold ones, and 2 clear ones. If you pick a blue, you get $5. Pick a gold, you lose $3. If you pick a clear marble, you lose $2. So now we'll make our table. So we can get a blue marble when we draw a marble. Again, another super exciting experiment / game. You're picking a marble from a bag. It's something slightly more interesting than flipping a coin, right? So we can get blue, we can get gold, we can get clear. What a boring marble color, clear. Much rather get blue or gold. If you pick a blue marble, you get $5. Gold marble, you lose $3. That's negative $3. Clear marble, you lose $2. That's negative $2. Probability, well, there's 10 total, right? 5 blue plus 3 gold plus 2 clear. So blue, it's a 5 out of 10 probability, 0.5. Gold, there's 3 of those, so that's 3 out of 10, or 0.3. And there's 2 clear marbles, so 2 out of 10, or 0.2. And the probability should always add up to 1. So it's never bad to check. 0.5 plus 0.3 plus 0.2 does equal 1, so we're good. We multiply across. So 5 times 0.5 is 2.5. Negative 3 times 0.3 is negative 0.9. And negative 2 times 0.2 is negative 0.4. If you add these together, 2.5 plus negative 0.9 plus negative 0.4, you get 1.2, which means which means an expected value would be $120, or $120, $1.20. So the question was, how much would you charge for the game to be fair? So fair game, again, is where expected value would equal your cost to play. So if our expected value is $1.20, you would charge $1.20 to play.